lesson in Unit 5. So let us start, guys. What is the pH scale is our main question in this lesson. So the pH of a solution is a measure of how acidic or basic a solution is. According to that, guys, a solution that has a pH value of exactly 7 is neutral. So this solution is neither acidic nor basic. While a solution with a pH value of less than 7 is considered to be acidic, and here there are more hydronium ions than hydroxide ions in the solution. The third kind of solution is a solution with pH value greater than 7. So here this solution is considered to be basic, and in a basic solution there are more hydroxide ions than hydronium ions. So you may remember that last time we discussed about the difference between acidic and basic solution, and we say that acidic solution will increase the concentration of what? Of hydronium ion, while the basic solution will increase the concentration of what? Of hydroxide ions. And we say that usually we classify the acids and bases into strong acid and strong base, and weak acid and weak base. And we say that, for example, strong acid will produce much more amount of hydronium ion than the weak acid do. The same is for the bases. The strong base will produce much more hydroxide ions than the weak base do. So according to that, guys, you may remember that we discussed about something called the litmus paper, and litmus paper is a kind of paper that is used to identify whether the solution is an acidic solution or a basic solution. Okay, so now we say that, for example, the red litmus paper will change its color to blue in what? In basic solution, while the blue litmus paper will change its color into red in acidic solution. So the litmus paper is useful as indicator to just identify which solution is acidic, which solution is basic, but it will not identify how much certain acid is strong or how much certain base is strong. So it will just identify whether the solution is acidic or basic, but it will not indicate the strength of this acid or the strength of this base. So today, inshallah, we'll discuss about a way so we can use it to identify the strength of certain acid or certain base. Okay, guys. And this tool actually measure the pH of a solution. So it will depend on what? It will depend on the pH of solution, or it will depend, in another word, on exactly how many hydronium ions do we have in this solution, or how many hydroxide ions do we have in this solution. So for example, as we said, if the number of the hydronium ions is equal to the number of the hydroxide ions, then this solution is called what? Is called neutral solution, and the pH value here will be exactly 7. Okay. So what is the pH of some common solutions? Lemon juice, for example, guys, we know that lemon juice is a kind of acidic solution, and lemon juice has a pH of about 2. Milk, for example, has a pH of about 6.5. So according, guys, to this value, we can know now that milk is a kind of acidic solution. Why? Because, as we said, all acidic solution has a pH value that is below 7. Okay, what about sour milk? Sour milk has a pH of about 4 pH, so it's much acidic than the other kind of milk. Okay, so guys, what about pure water? Pure water is neither acidic nor basic, it's neutral. So since we are saying it's neutral, then we expect that the pH value of the pure water will be 7 exactly. Guys, a solution of ammonia, you remember that we talked about ammonia, and ammonia has the chemical formula NH3. So ammonia has a pH of around what? 12. So guys, ammonia, as we know, is a kind of a strong base actually, and it's a base. Why? It's a base solution because its pH value is greater than 7. Okay, what about the antacid tablets? Later on, inshallah, we discuss about antacid tablets and what we are using these tablets for. Okay, so antacid tablets dissolve in water to form a basic solution of about pH 8. So again, antacid is kind of a base because it has a pH value greater than 7. Okay, so we have a question here, guys. Locate lemon juice, milk, pure water, and ammonia on the pH scale. As we said, lemon juice, for example, let's go back to the previous slide. The pH value of lemon juice is 2, so lemon juice will be here, guys. Okay, it will have the orange color. Okay, so what about the milk, guys? Remember, milk has a pH of about 6.5, so it's as you can see here, the lemon juice is more acidic than the milk. Also, guys, there's important note that you should know that as you go to the edges of this scale, the acidity will increase, and the same will be for the basicity. So solutions that will be here at 14 or solutions that will have a pH equal to 40, for example, are more what? They are more basic than the solutions near to 7. For example, solutions that have a pH equal to 8 or 9. So as you go to the edges of this scale, the acidity and the basicity will increase. But as you move toward the center of this scale, and exactly towards pH 7, the acidity and the basicity will increase. So here, for example, lemon juice is more acidic than milk. Okay, so what about pure water? Remember, we say that pure water has a pH equal to 7, so it will be right here, guys. It's a neutral substance, exactly as 7. Okay, what about ammonia? Ammonia, we say, is a kind of base solution, and it has a pH value equal to 12, so ammonia will be exactly right here. Okay, so now how is pH measured? If I want to measure how much certain acid is strong or how much certain base is strong, of course, as we say, we are not gonna use just the litmus paper, but we need to measure exactly the pH value of these solutions. And actually, we have several ways to measure the pH value. One of them is what the universal pH paper looks exactly like the one here. Okay, so guys, the pH of solution can be checked by placing a drop of the solution on a strip of universal pH paper, which contains several acid-base indicators, exactly like the one you see it here. Another way is, guys, an acid-base indicator, which is a kind of dye that changes color at certain pH range. The pH can be estimated by placing a few drops of indicator on a solution. So if you have a solution like HCl solution, which is acidic, you'll place drops of this indicator into these solutions, and you will recognize then the changing color, and you will again you will identify whether this acid is strong or this acid is base by comparing the color here with the pH range you have. The third way, guys, is using the electronic pH meter. Electronic pH meter has a probe that is placed into the solution being measured, and then precise pH value will be shown. So a natural pH meter, guys, here we have a kind of plants called hydrangea. Actually it's a beautiful kind of plants and it's so interesting. Why? Because it acts as acid-base indicator in nature. So the flowers, the hydrangeas, change color depending on the pH of the soil. So pink flowers indicate that the soil pH is greater than 6.5, so it's a basic soil, while blue flowers indicate that the soil pH is less than 5.5, so the soil is gonna be acidic. So the color of the flower here will be affected by what? By the type of the soil, if it is acidic or if it is basic. So if the soil is basic, we will have what? We'll have a pink flower. But if the pH of the soil is less than 7, then it's an acidic soil, then the colors of or the color of flowers will be what? Will be blue. Affected. So now, guys, an important question: what role does pH play in the environment? And guys, we'll see that actually pH is gonna affect everything around us. It's gonna affect the soil, and then it will affect the plants and animals as well. It has effects on what? Also on the water in oceans and in rivers and so on. So if you want to discuss the effect of pH on soil, for example, if soil pH is too acidic or too basic, then nutrients plants need do not dissolve very well into the water in the soil. So if the nutrients is not being absorbed to the water and the soil, then the plants will be affected. So plants do not grow well, and the animal population that depends on the plants also will suffer. What about the pH of the ocean water? Guys, the pH of ocean water is usually about 8, so it's slightly basic. If the water absorbs too much carbon dioxide from the pollution, for example, the pH may be lowered, harming sea animals. Another important thing we need to discuss about, guys, is the acid rain. What causes acid rain? Acid rain is any form of precipitation such as rain, sleet or snow that has a lower pH than the normal range between 5 and 6. So now, what will cause the acid rain, guys? The burning of fossil fuels releases harmful gases such as sulfur oxides and nitrogen oxides. These harmful gases, then will combine with the water in the air to produce a harmful acid such as sulfuric acid and nitric acid. Then these acids would accumulate in the atmosphere, and in a rainy weather they would form acid rain when they dissolve in precipitation such as raindrops. So now this acid rain can lower the pH of lakes, the ponds, all the water bodies, harming aquatic species and other organisms that rely on the water for survival. Acid rain can also harm plants by damaging their leaves. It can also harm plants and other living things by what, as we discussed before, by lowering soil pH. And if the pH of the soil decrease, as we said, the nutrients will not dissolve well in the water of the soil. So guys, you can imagine that acid rain can also damage buildings and drops and stones that's mainly made of limestone and marble by reacting with the stone. So actually it has a very powerful effect. Acid rain can also damage paint and cause metals to corrode faster. So where does pH play an important role in the human body, guys? We have here our stomach. Actually the stomach produces kind of acid, which is the HCl. And HCl in our stomach is very important. Why? Because it will defense against what? Against the microbes, since most of the microbes cannot survive in an acidic solution. So stomach pH is usually about 2.5, but a food that is difficult to digest is 18. More stomach acid is made, so more HCl will be produced, and the acidity then will drop as low as 1.2. So difficulty in digesting food and a low stomach pH can cause what can cause discomfort called indigestion. So guys, sometimes when there is an extra acid is produced in our stomach, this extra acid will be reflected into our chest, and it may also reach our throat, so you can feel like there's something burning inside your chest. So guys, here, in order to neutralize the acidity and to solve this problem, you may consume a kind of tablets called antacid tablets. So antacid tablets will neutralize the extra acidity, and it will restore the pH back to a normal level. So guys, the antacid tablets are basic in case you have difficulty or indigestions, as we said, and extra acidity is produced in your stomach, so you can just consume antacid tablets that will neutralize the acidity and restore the pH value back to a normal level. So another place, guys, where pH will play an important role in our body is our blood. To maintain good health, blood pH needs to be between 7.35 and 7.45, so it's kind of a neutral solution. So if blood pH falls below 7.35, it's too acidic, and this condition is called acidosis, while if blood pH rises above the normal value, which is 7.45, is too alkaline, and here medically this condition is called alkalosis. Okay, so both conditions actually will make a person feel ill. So for a healthy body, the pH level should be between should be within this range, which is 7.35 and 7.45. So guys, as you can see here in this diagram, acidosis, as we said, is when the pH value of the blood is lower than 7.35, and here, guys, it will or the patient here will suffer from several symptoms such as headache and vomiting and others. What about, guys, the alkalosis condition? Alkalosis, as we said, the pH value will be higher than 7.45, and again, guys, it will affect the person's health, and it will cause irritability, weakness, and cramping. So guys, that's all for today. Thank you, and see you inshallah tomorrow.